So the procedure for finding yp is complicated, admittedly so. But we can learn to do that. Just
focus,
right? And it's called variation of parameters. And what we're going to actually do, before I get into the details of it, is this complementary solution, or solution of the homogeneous equation, instead of having an arbitrary constant c, we're going to replace that with not a parameter number like a constant c. We're going to replace it with a variable function. So that's what happens. We take our yc, we replace this constant with the variable function u of x. This y1, by the way, is just this right here, whatever our non-constant part of the homogeneous solution is. Okay, the solution of the homogeneous equation. So that's what we're going to do, and that's why it's called that. We're going to replace c with a variable parameter, like a function u of x. And then we'll try to find it. Now, since yp, this u of x times y1, is a particular solution of the equation, then we should be able to substitute it back into the equation and solve. We know it's a solution. See what happens is, we know it's a solution of this equation, or we're making the assumption that it's the solution of this equation, and then we're going to see if we can't find it. Well, it turns out that if you just plug that into the original equation, see, there's the f of x, so this is not the homogeneous. This is replacing our y. This is replacing our y, so the derivative of y plus p of x times y equals f of x. And you may recall, that's the original function. So now we're going to go ahead and differentiate this u of x times y1. So that would be first d second, so u of x times dy1 dx, plus second, that's y1, d first, which is u prime times y1, plus p of x times u of x times y1 equals f of x. So all we did was differentiate this part. But now we're going to reorder things. I'm going to take this term and put it where this one is, and take this one and we'll move it over here a little bit, okay? And so notice, if I take this term and this term, they both have a u of x in them, so I factor that out. I have a u of x times d of y1 plus p of x times y1, see? And then plus this u prime x times y1 equals f of x. Which you're thinking, well, what good did that do? Right? Are you thinking, what good did that do?
I agree.
Right, so what good did that do? But wait a minute. Since y1, which is just this with a 1 here instead, is a solution of the homogeneous equation, then what is the derivative of y1 plus p of x times y1 equal to?
That stuff coming up.
Yes, it's equal to 0, because it's a solution of the homogeneous equation. So this whole mess right over here, this is 0. So we just have u1 prime times y1 equals f of x. Right there. Or better yet, u prime equals f of x over y1. So f of x over our yc, with c equal to 1, so here it is. u1x is this. Remember, this was yc. Well, I have a constant in there, but I made the constant 1. And then we're trying to find u, remember? Well, integrate both sides of this equation, and we have our u. So u of x equals, ready? Integrate, integral of this. It's ugly, I admit, but we can do it. Because this is going to be some known function. By this time, we've figured out what this is. So we'll integrate f of x over this, which is, by the way, called our integrating factor. So that's the integral of, but notice that the negative exponent in the denominator moves it upstairs, so you could work that out without too much difficulty. So f of x dx, and now our yp is this u of x times our yc. Remember what our yc was. This is actually mostly our yc, it's in the denominator though. So that means our yp is this u of x times yc. So after we assume c equals 1 for simplicity, but we already did that. So now the solution to the equation is yc that we found first plus this yp that we just found above. So here's the yc plus this thing from here. That's, this thing from here, which is our u1, times this, which is our yc. Wow, what a process. What a process.
I think that this is your way of telling me something.
I'm trying my best.